Hi everyone. So Chapter 1 is all about methods for collecting data and then looking at data, the context of data, and classifying data. In Section 1.3, we look at observational studies and experiments and talk about the difference between the two. We look at observational studies and experiments when we want to look to see whether or not two variables have some kind of relationship, whether it's a correlation or a causality. And by the way, we will talk a lot more about correlation in Chapter 4. So with observational studies, researchers passively observe the variables to determine if there's a correlation. They don't manipulate anything. Experiments, on the other hand, researchers manipulate the explanatory variables, like that first variable, to see if it causes the second variable. So the researchers will specifically manipulate that explanatory variable. With observational studies, we have to be really careful of what are called confounding variables. So these are the variables in the background that we're not specifically looking at that could still be influencing the two variables that we are looking at. So like, for example, say we want to look at ice cream consumption and number of sunburns at local clinics, right? And maybe as the ice cream consumption goes up, the number of sunburns at the local clinic goes up. Can we really say that ice cream consumption causes sunburns? No, absolutely not. We cannot say that. We have a confounding variable in the background, which is basically how hot and sunny it is outside. Because we all know the warmer it is, the more likely people are to go get ice cream and the more likely they are to get a sunburn. So that would be an example of a confounding variable. In an experiment, we use randomization to account for these confounding variables. And for that reason, with an experiment, we can determine that one variable will cause another variable. We can't do that with observational studies. It's really important as you're reading your textbook that you notice the difference between these two and that you pay attention to the difference between correlation and causality. So there are different types of observational studies. So the first classification is the difference between cohort studies and case control studies. And then under cohort studies, we have prospective studies, cross-sectional studies, and retrospective studies. So cohort studies mean that we have a group of subjects and we're studying whether or not various factors are associated with some kind of outcome. In a prospective study, we would choose the subjects first and then we would follow them through time. So say we wanted to look at how preschool education affects high school graduation rates. And so we choose a group of toddlers and families and we follow them to see whether or not they are involved in preschool education, and then follow them throughout their K through 12 years and then see if they graduate from high school. And we collect all that data moving forward. So you can see that prospective studies take years of studying. Cross-sectional studies are when a certain measurement is taken at a single point in time. So maybe, for example, my dad has MS, so I hear a lot of studies about MS. And so maybe take a group of subjects and they measure their vitamin D levels and then look at whether or not they have MS. So there was a measurement taken at a single moment in time to look at vitamin D levels and their correlation with MS. You cannot look at this as a causality because there's too many other confounding variables in the background. A retrospective study is when all the data already exists, but you're collecting a sample of subjects and then you're going back and collecting that data. Case control studies are when you have two samples that are taken and investigators look back in time to see whether or not a factor of interest differs between the two groups. With case control studies, it's always retrospective. They're always looking back in time. So with experiments, the researcher, the experimenter, is going to actively manipulate that first variable, that explanatory variable. And they're going to do this by randomly assigning subjects or individuals to different groups, different treatment groups. So one experiment that I heard of that was kind of funny and interesting was how alcohol consumption affected test results. And so they had a large group of students, college students of drinking age, and they randomly assigned them to different treatment groups. One group, had maybe just one drink, and another group had 2 drinks, and so on. And so they had different treatments to this first variable of alcohol consumption. And then they looked at how each treatment group performed on a test. The baseline group or the control group would be the group where the treatment wasn't applied. So in the example I was just using, it would be, say, a group where they didn't consume any alcohol at all. The randomization of this grouping is what is going to account for confounding variables, because you figure that all of the subjects are going to have a mix of confounding variables. So if you are randomly assigning them to each group, you're kind of accounting for those variables, even if you're not sure what those variables are. There are 2 types of blinding when it comes to experiments. There's single blinding and double blinding. Single blinding is when the subjects don't know which group they're in. With the example that I gave, there's no blinding at all, right? The subjects would know which alcohol consumption group they're in by how much alcohol they're being given. So there's no blinding there, but single blinding would be where a subject doesn't know which group they're in. And double blinding would be where neither the subject nor the treatment administrator would know what group they're in. So with double blinding, I always think of Grey's Anatomy, and there was some episode, they were doing an experiment with a drug treatment, and I forget, it was Alzheimer's or something, and the doctors were just given a syringe, and they had to, insert the medication into the patient, and neither did the doctor nor the patient had any idea if that syringe was the placebo or the actual medication. And there was somebody else in the background that was, monitoring everything on a computer. So that would be double blinding. So I do have another example of an experiment here. I found this last semester and I thought it was interesting. So if you want to see a quick snippet of a real life experiment and some of the results that came from it, you can go to the website up here. This is from NPR. If you read my intro, I love NPR. So this said there was a California city, and they selected people and just gave them $500 a month for 2 years. No strings whatsoever attached. They just gave the families $500 a month. No drug tests, no work requirements, nothing. And then they looked to see how this affected those families compared to families that were not given the money. And what they found, and by the way, this was in a city that was really struggling financially. So what they found was that many of the families spent the money on essentials like food and home goods and utilities and gas. So they weren't wasting the money. And that actually full-time employment grew significantly from 28 to 40% for people who were given the money versus people who were not given the money. So I thought that was a very relevant experiment. So go ahead and read about that. But you have another experiment example in our assignments.